I'm going to do a video with two quick examples, one having to do with modeling area using quadratics and the other one dealing with vertical motion. So this first problem is an area problem. A company is offering rectangular pool sizes with dimensions as shown, and as you can see in the dimensions, there's some X's involved. Each pool includes a deck around it. If Carolina wants a 15-foot wide pool and with a deck, how many square feet will she need to have available? So the first thing that we want to do, and really the most important thing we want to be able to do, is write a quadratic function to represent the area of the pool and the deck. So we want to write an equation or an expression that represents the area of this whole pool. Okay, now this is a rectangular shaped pool, so to find the area of any rectangle, we do base times height. Now this is a very similar problem to what we did in previous units. However, we have less dimensions, I guess, or no less numbers. So what we need is the length of the base and the length of the height, or how high the pool is. So what we're going to start with is by saying, okay, I know from here to here is 2x, but I want to know the whole base. So the whole base includes the deck around. We know the distance around the pool, 4 feet, on both sides. So when I put all three of those things together, I add all the pieces up. So I would have 2x plus 4 plus 4. I wrote it in this way because it's a little easier to see combining like terms, because I can add the 4 and the 4 together to get 8. So now the length or the base of this pool is 2x plus 8. We're going to do the same thing with the height. I know part of this height is x, all right? That's the width of the pool, or the height of the pool. And then I want to find the whole height of this pool with the deck, and I know the deck is 4 feet. So if I combine all that information together, I have x plus 4 plus 4, oopsies, which gives me, when I add the 4 and the 4 together, x plus 8. So now when I go back up here and I'm thinking about, okay, I want to find an expression for the area, I know that my base is 2x plus 8, and I know that my height is x plus 8. Well, what we want to do is we want to multiply those together in order to get a nice expression in standard form. We have different methods of multiplication. I'm going to show the box method here, which is where I say, okay, my two binomials are 2x and a positive 8, and an x and a positive 8, and I'm going to multiply the things that meet in the box. So that first one would be 2x squared, second one would be 16x, then 8x, and 64. So the expression here is 2x squared plus 16x plus 8x plus 64 when I combine all those together. And then I have some like terms. So I have 2x squared plus, let's see, 24x plus 64. That would be an expression that represents the area of the pool and the deck together. The next type of question from 8.4 was dealing with vertical motion. This is something that we have talked about in previous chapters as well. We are sometimes throwing a ball, sometimes kicking a ball. In this case, we are diving off of a diving board. So a diver is jumping off of a high platform at an initial vertical velocity of 16 feet per second. So we are going to use this general form that models a vertical velocity problem. This will be given to you on the test, so you don't need to memorize it. Now, there are a couple variables in here that you need to know. V sub O, or V little o, or VO, or what, V naught, sometimes people call it, stands for the initial velocity. Okay, H sub O, or HO, or H0, or H naught, there's a lot of different ways you can say it, stands for the initial height. Okay, the negative 16 t squared will stay the same. There will always be a t after your initial velocity, and then the h, or the initial height, will be at the end without a variable. You should be able to pretty easily pull these pieces of information from the problem. A couple tricks that might end up happening, I'll talk about at the end. So we want to write a quadratic function that represents the height of the diver after t seconds. So I'm going to use this general form. I'm always going to have the negative 16t squared. Then I'm going to add the initial velocity, which they told us was 16 feet per second. And then I put a t after it. And then I need my initial height. Well, they didn't tell me my initial height, but in looking at the picture, I can see that this diver, the platform, was 30 feet high. So I'm going to put a plus 30. So this is the equation for that models this diver's path. A couple of things that might happen with the initial height. Let's say I was kicking a soccer ball. Okay, I'm a terrible drawer, but here's my net, okay, for my soccer ball. Awesome, right? And here's my player. And I'm going to kick the soccer ball. What is the initial height of the soccer ball? Well, it's starting at the ground, right? So if something starts at the ground, the initial height would be 0. It's starting 0 feet off of the ground. So just kind of keep that in mind because that might show up at some point. B, how many feet above the platform will the diver be at the highest point of his dive? So this is kind of requiring us to remember some things about quadratics. Okay, here's the path. His highest point is right there. That is called the vertex. All right, a vertex is a point, x comma y, and we can find the vertex of something in standard form by starting with this equation, the opposite b over 2a. So in this problem, my b is 16, so it will be negative 16 divided by 2 times negative 16, which is my a. So that would give me negative 16 divided by negative 32, which is 0.5. All right, that is the x value of my vertex. Now, the question is, we want to know, are we trying to find x or are we trying to find y? Because let's be honest here, we don't even have x's and y's in this equation. We have t's and h's. So what variable is in place of the x in this quadratic? Okay, we don't have x's, we have t's. So what we really found was the time it took for that diver to get up to its maximum height. So x is really our time, or t. So the y is going to represent the height, or h of t. Anytime we know the x, we can plug it into the equation in order to find the y, or in this case, to find the h. So I'm going to take my 0.5 and I'm going to plug it into that original equation in order to find h of t. I plugged that into my calculator and I ended up getting 34. So my vertex technically would be 0.5, 34. But you want to be careful about what they are actually asking you for. They are not asking us for how much time it takes. They are asking us for the height. So the height, or how high that diver is at its maximum height, would be 34 feet in the air.